Hello, advanced algebra students, and welcome back to another video lesson as we continue to look at properties of exponents. Today we will be focusing on those negative exponents and what that property illustrates. But before we get there, I want to tie up yesterday's video by trying a warm-up. What if all of the exponent properties are combined in one problem? All of them right here. Can you simplify? Try your best. So pause the video here. Try as best as you can to see what you get. All right. When we have all of them in one, we really need to start inside of the parentheses and apply this to maybe at the very end once we've simplified as much as we can. And then we're going to look at the numerator denominator kind of separately. So the first thing I'm going to focus on is rewriting this right here. And that means 2 to the third x to the 1 to the third. 2 to the third is 8. X to the 1 to the third becomes x to the third. And then I've got x to the fifth, y to the seventh. So that's my numerator. Now, is there anything else that we can actually combine in the numerator? Because it's all being multiplied, we certainly can. We have some x's. And again, imagine if I listed all of them out, we'd have 3 x's and 5, leaving us with x to the 8th. So 8x to the 8th, y to the 7th. That's our numerator. Then, let's take a look at what we have on the bottom. 4x to the 5th, y squared, z to the 0. Anytime you see something raised to the 0, you can kind of cross it out and replace it with a 1. It becomes 1. So 4 times x to the 5th, y squared times 1 gives me 4 x to the 5th, y squared. Because 1 times that 4 is out front. We said the top was 8 x to the 8th, y to the 7th. All right, and now let's use our rules here that we also learned yesterday. 8 divided by 4 gives me 2. X to the 8th over x to the 5th, that is really x to the 8 minus 5, which gives me x to the 3rd. Y to the 7th over y squared, well, that's really y to the 7th minus 2, or y to the 5th. And then all of this is being raised to the 2nd power. Right, so I simplified everything on the inside first, and then I have to remember that I have it to the 2nd, which means I have 2 of these. 2 squared, right? 2 squared is 4. X to the 3rd squared is x to the 6th. Y to the 5th squared is y to the 10th. So this is our simplified answer. This is just testing your knowledge on all of those properties and rules. But what happens when we start to get some of these negative exponents? That first one up there says x to the negative 3. And it's a little bit of a challenge because the only rule that we really have with these negative exponents is to basically turn it into a fraction and move it to the denominator if it started in the numerator. So this becomes 1 over x to the 3rd. What about v to the negative 8th? Well, since it's starting out as negative 8th, we move it to the bottom and it becomes v to the positive 8th. Well, what happens here, right? Because it's on the bottom, we actually end up moving it to the top. And let me try and show you why. If it was just 1 over this, we would replace this by saying it's 1 over p to the positive 4th. But to rewrite this means 1 divided by 1 over p to the 4th. And to divide by fractions means to 1 multiply by its reciprocal. So instead of doing that process the entire time, we can just say that we're going to take and move this to the top. Y squared stays on top because that was a positive exponent. And then p to the 4th is moving to the top. Is there anything to combine? Anything with the same base? Well, there's not, so we would leave it just like that. In this one, t to the negative third, though, to make it positive, we move it to the denominator. P to the negative seventh, to make that positive, we move it to the numerator. 2 to the negative third, we move it to the bottom. 2 to the third, but 2 to the third, 2 times 2 is really 8, so 1/8. 1/8. All right, the rule yesterday on letter F was to subtract. H to the 3 minus 10 gives me H. I should make sure that's up on top. Sorry about this. H to the negative 7th. 3 minus 10 is negative 7. We should never leave negative exponents in our answer, which means we need to move that to the bottom. If you think about writing this one out, I'd write 3 H's on top, 10 of them on the bottom, meaning I'd have 7 left over on the bottom once we canceled them. Okay, so here's the basic rule and idea. If we have a negative exponent in the numerator, we move it to the denominator and make the exponent positive. So if I have some base raised to the negative n, we turn it into 1 over b to the positive n. But if it already started in the numerator, b to the negative n down here, we make it positive by moving it to the numerator. So that's the rule for negative exponents. And it's still, our previous rules from yesterday still apply as we try to simplify some of these. So we're going to take a look at a lot of different examples, 6 of them, tying a lot of this information together. 4 to the negative third. Well, it starts out in the numerator, so we have to move it to the denominator, making it 1 over 4 to the third, and then we're going to simplify. Because it's asking us to simplify, we have to calculate what is 4 to the third. 4 times 4 is 16, times 4 is 64, or we get 1/64. 1/64. Letter B, 2/5 to the negative 3. Yesterday's lesson told us that we had to apply that to both the numerator and the denominator, which I just did right there. Well, what happens if we have negative exponents? We've got to move them. 5 to the third moves up top. 2 to the third would move onto the bottom, and then we simplify. 5 times 5 times 5, that's 125. 2 times 2 times 2 is 8. Those do not simplify, so we can leave it as 125 over 8. But again, we got to make sure we apply that negative 3 to both the numerator and the denominator. Letter D, 5 to the negative 4th times 5 to the 8th. Right? They have the same bases, so we can add their exponents. Negative 4 plus 8 gives me 5 to the 4th. 5 to the 4th. Notice I didn't have to do anything with that negative exponent because we could add it together and it ended up going away. And 5 to the 4th is really 5 times 5, 25 times 5, 125, 625. So we get 625. So we're starting to combine all of these rules together, trying to figure out a way to best represent them in one final solution. Letter E, 4a to the 4th times 2a to the negative 3rd. So this group is being applied to the 4th. So I raise 4 to the 4th, and then I do a to the 4th times this group is being raised to the negative 3rd. 2 to the negative 3rd, a to the negative 3rd. Okay. 4 to the 4th. 4 times 4 times 4 times 4. 64 times 4. 256. A to the 4th. I'm going to move this piece to the bottom, right? Because it has to become positive. And I can leave the a to the third up on top or to the negative third up on top for now, because I have another a to the fourth right here. And what's going to happen with these two? Well, a to the fourth times a to the negative third means I add their exponents. A to the 4 plus negative 3, leaving me with, it's not 560. Why did I write 560? 64 times 4 is 256. Sorry about that. So we've got 256. A to the fourth times a to the negative third. We add their exponents and I get a to the first all over 2 times 2 times 2, which is 8. And then I need to check and simplify 256 over 8. And so it's okay to use a calculator. 256 divided by 8 is actually 32. And so we get 32A for letter E. Again, knowing those properties, applying the 4 to both of those, applying the negative 3 to both of those as well. One more example to look at, which again ties a lot of these properties all together as we get ready for a mini test scheduled on Friday. All right, so you'll notice, kind of like our warm-up, we've got a lot of information here. Not much is happening to the numerator. There's nothing to combine together because there's different bases. Nothing here, but we do have this 2 outside the parentheses. All right, so I'm going to leave the top alone for the moment. P to the negative 3, Q squared, R squared, all over. This 2 goes to all 3 of them, so 3 squared, or 9, p to the 6th to the second. So p to the 6th raised to another second gives me p to the 12th. R to the negative 3 to the 2. So r to the negative 3 to the second. Multiply those gives me r to the negative 6th. Okay, so I'm hoping you see how I got that. Step number 2 after that is I'm going to combine what I can combine, all right? P's being divided. So the P's are going to give me P to the negative 3 take away 12, or P to the negative 15, right? If I subtract them, I'm going to get P to the negative 15 up here. There isn't anything to combine with my Q's, so Q to the second can stay up here. And then the R values, we've got R to the second, take away negative 6. Take away negative becomes plus positive, or R to the 8th. Is there anything inappropriate that we need to change? You bet. This P to the negative 15th. So only that piece, only this piece gets moved to the bottom because the other ones already have positive exponents. 9 stays down there, and we're bringing P to the 15th down so that becomes our simplified version. Again, that incorporates 1, 2, 3, 4, maybe 5 of the different properties that we've learned all within one problem. Please make sure you try those practice problems today and give yourself a better chance on the mini test that's coming up on Friday. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.